Hello student, let us see one problem of backpropagation. We are updating weights in output layer. So W5, W6, W7 and W8. These 4 weights we are going to update. B2 or this B1 can be updated in different ways. But now only we are updating these 4 weights W5, W6, W7 and W8. So let us see. First you are applying forward propagation to find out values of output 1 and 2. These are the given values 0.1 and 0.99. Whatever the calculated value and the targeted value, we will compare them to find out the error. And to minimize that error only, we are updating all the weights. But in this problem, we will just update these 4 weights. So let us see how to find out the solution. In class also I told you, don't get confused for notations particularly. So in forward pass, what is expected? Now see what is the difference in notation. Inputs are denoted by I1, I2 instead of X1, X2. Here then H1, H2 it is given. So net input or weighted sum every time we are denoting by Z1, Z2. Here you will get the output also by applying the activation function, and that output will work as an input for the next layer. So let us see how to solve this problem. All the weights, inputs, bias values, targeted values are given here. So first we are applying forward propagation. So forward propagation, so let me use here the notation as Z1. This is our net input, Z2, and here whatever output we will find out, let me denote as Y1 and Y2. Here again we will get Z3 and Z4. Okay, and the output we will find out. So O1 and O2 it is given here. So let me consider O1 and O2. These are the output 1 and output 2. And let me consider YT1 targeted value, it is equals to this is given as 0.01. And here second targeted value YT2 it is equals to 0.99. So we are applying forward propagation. So for the forward propagation, see, I am not calculating all the values because you can also find out it. I am just showing you how we are applying overall process. So we are starting with Z1. Z1 is equals to, now carefully see Z1. So which are the contributing weights? W1 as well as W2. These are the contributing weights. So W1 connected with I1 and W2 connected with I2. What formula we are using actually? Summation of Wi Xi plus B1. So here it gives me I1 into W1 plus I2. Now Xi, instead of Xi we are considering it as I1 and I2. I2 into W2 plus B1. Immediately we will find out output here Z1, so output it is Y1. How you will get the output? Y1 it is equals to, we are applying activation function. So the most complicated activation function is sigmoidal. So let me apply this. So this is equals to 1 by 1 plus e to the power minus Z1. So it will gives you that value of Y1 output. In similar way, let me find out Z2. Now for Z2, see, the contributing weights are W3 and W4. W3 connected with I1 and W4 connected with I2. So Z2 it is equals to I1 into W3 plus I2 into W4 plus bias it is again same, bias it is equals to B1. Immediately you can find out Y2. So Y2 it is equals to phi of Y2 it is equals to phi of Z2. So which is equals to 1 by 1 plus e to the power minus z2. So for the first layer we calculated the output, but one more layer it is given here. So let us find out output for the next layer. We need this figure every time in front of us. So even though it's given in question paper, you should draw it in your answer sheet also. Now let us go for the next layer. Now y1, y2, they will be treated as input for the next layers. So Z3, to calculate Z3, now see W5, W6 are the connected weights. W5 connected with Y1 and W6 with Y2. So let me write down now Z3. Z3 it is equals to Y1 into, let us check one more time, Y1 into W5 and Y2 into W6. Y1 into W5 plus Y2 into W6 plus bias is there. Don't forget to take values of bias. So bias is B2. Immediately find out the output. Output it is equals to O1. I will repeat one more thing. Don't get confused in any notations. Your calculations are more important. O1 it is equals to phi of. We are applying activation function on the weighted sum. O1 it is equals to phi of Z3, that is 1 by 1 plus e to the power minus Z3. Similarly, find out Z4 net input, that weighted sum. Let me show you again. So for Z4 the connected weights are W7, W8. W7 with Y1 and W8 with Y2. So Z4 it is equals to Y1 into W7 plus Y2 into W8 plus bias B2. All the values are given to you. Y1, Y2 you calculated. So these values only need to be substituted here. O2. So O2 it is equals to phi of Z4. So this is equals to 1 by 1 plus e to the power minus Z4. We can calculate O2. All the values are calculated, and see here we will observe the O1, O2 and targeted values, whatever the given targeted values, they are having a difference, and our aim is to minimize this difference, and to train our neural network for the better performance we are updating weights and bias. So we want to update the weight and bias now. So to update the weight and bias, so our aim is to minimize that error. So what is the error? We will get two errors now. E1, let me consider E1. So what is E1? E1 is nothing but difference between O1 and YT1. E2 is nothing but difference between O2 and YT2, and the final difference, average of these two, it is nothing but the final error. So E, it is E1 and E2 is there, but let me consider E. E it is equals to, two errors will be there. Let me consider E1. E1 it is equals to half YT1 minus O1 whole square. This is E1, and E2 it is nothing but, E2 it is equals to half YT2 minus O2 whole square, and average of this two, it is nothing but the error E. Separately we are considering both of this error, which will contribute to the final error E, which can be calculated by using the error E1 and E2 both. So let us consider separately E for first and E for second output. So now what weights we are going to update? Let me show you again. W5, W6, W7 and W8. Matrix form we are using generally here. So how or what matrix, for which two weights we should use the combination? So O1, which are the two weights contributing to O1, W5 and W6. So consider it's one matrix. And O2, W7 and W8 are contributing to O2. So consider their matrix. So I will repeat. Instead of separately finding that weight updation for W5, W6, W7, W8, we are considering the matrix form. So which two weights we are considering in combination? So W5, W6 contributing to O1. So we will consider a matrix of W5, W6. And in similar way, W7 and W8 are contributing to O2. So we will consider matrix of W7 and W8. So let me show you this. Now two errors you are considering. E1 you are observing. E1 we are considering. YT1 it is given as some constant. E1 it is function of O1. O1 it is function of, let me show you what is O1. O1 it is function of Z3. And what is Z3? Z3 it is function of W5 as well as W6. So E1 it is equals to O1. O1 it is function of Z3, and Z3 it is function of W5 as well as W6. It is function of both W5 and W6. See, both are contributing here. So by observing this chain, now when I am writing updated weight of what? W5 and W6 is equals to, new values we are finding, is equals to W5 W6 minus alpha del E by del Wi, where we will consider del E by del W5 as well as del E by del W6. So as we discussed, we are going to write down this in matrix form. So let me consider that formula in matrix form only. What kind of derivatives will be there? So separately I am writing this del E by del W5 and del E by del W6. Separately we are writing the derivatives. See this, del E by del O1 into del O1 by del Z3 into del Z3 by del W5. Three derivatives. Again here del E by del O1, because you are observing the chain for W5 W6, W5 function of Z3, Z3 O1, O1 function of E1. So same thing is there. So if you are having any confusion, let me write down it as E1 E1. No issues, because final E it is calculated by using E1 E2, but this W5 W6 are contributing to E1 only. Now again del E by del O1 by del Z3 again, and del Z3 by del W6. So from this derivative itself we will observe first two derivatives will be same and third derivative is different. So let us write down this del E by del O1. What is the value of E? This is nothing but value of E. So if you are finding derivative of this with respect to O1, 2 into YT minus O1 into minus 1. So if you consider this minus YT minus O1, this will be the derivative. Now we are finding del O1 by del Z3. Let me show you. O1 it is phi of Z3. Phi dash of Z3 it is nothing but derivative of this. Immediately let me show you one thing. Yes, let me show you this. Phi of Z is this, then phi dash of Z it is equals to this one. Okay, but every time calculating this complex value it is always difficult. That's why a small adjustment we are doing. This can be written like this one, and again this is nothing but actually जो कुछ भी आप output consider कर रहे हो y it is nothing but this. So this is replaced by y1 minus again this is replaced by y. So this small adjustment we are doing every time, and therefore what is this when we are writing this derivative? Del O1 by del Z3. You are calculating for O1 na, then O1 into 1 minus O1 done. सो जिसके साथ आप डिफ्रेंसिएशन ले रहे हो O1 का Z3 के साथ, सो O1 वट एवर दिस आउटपुट इंटू 1 माइनस दैट आउटपुट, इट विल गिव्स यू द डेरिवेटिव ऑफ O1 विथ रिस्पेक्ट टू Z3. एंड लास्टली Z3 विथ रिस्पेक्ट टू W5. लेट मी शो यू वैल्यू फॉर Z3 with respect to W5. Only one term of W5, remaining all are constant. So derivative of all these terms is 0, and derivative of this W5, derivative of W5 is 1. What is the constant multiplied? Y1. So Y1 will be there in the multiplication. And in same way here it is minus YT minus O1 into O1 into 1 minus O1, and only this last derivative it will be Y2. So let me write down it here. So this gives me minus term is there YT minus O1 into O1 into 1 minus O1 into a matrix will be there, because here Y1 and here it is Y2. So Y1 and Y2 done. So this is for updated weights of W5 and W6. Now let me write down for updated weights of W7 and W8. This updated values we are finding. So this is equals to W7 and W8 old values minus alpha. Again we are writing the same thing. So now W7 and W8, let me show you the chain again. Error we are considering, which is difference between O2 and YT2. Now O2 it is calculated from Z4, and Z4 it is calculated from W7 and W8. So let me write down the chain so that I can write down the derivatives. So the chain we are having is E2, it is function of O2, O2 is function of Z4, and Z4 is function of W7 and W8. So if I am writing the derivatives, del E by del E2, del E2 by del W7 and del E2 by del W8. Both of these derivatives we will find out simultaneously. Okay, so this will be del E by del O2 with respect to del Z4 and del Z4 with obviously del W7. Similarly del E by del O2 into del O2 with respect to del Z4 and del Z4 with respect to del W8. So finally what it gives me? Now see, del E by del O2, it gives me Y targeted 2 minus O2. Then derivative of this, what I told you, O2 with respect to Z4. So sorry, minus sign I was forgot. Don't forget this minus sign, then your value it will be totally wrong. O2 with respect to Z4, just like O1 with Z3, हमने क्या बोला था? O1 into 1 minus O1. Similarly O2 with respect to Z4 gives me O2 in bracket 1 minus O2, and Z4 with respect to W7. Let me show you what is the value for Z4. The value for Z4 is this one. W7 it is included in the first term only, and derivative of this with respect to W7 derivative is 1, and Y1 it is the multiplier. Similarly derivative of Z4 with W8 will gives you Y2. So here Y1 will be, and in second one minus of YT2 minus O2 into O2 into 1 minus O2 into Y2. So let me put here all the values. Again in bracket minus sign, I will repeat here, don't forget the minus sign, YT minus O2 into O2 into 1 minus O2 into the matrix of Y1 and Y2. So now all the values are in numerical form. You just need to put all this value to calculate the final updated values of W7 and W8. What will be the problems you will face? Mostly confusions for notation. Let me repeat one more time. Net input, weighted sum, we are denoting by Z1, Z2. If you are comfortable with other notation, you can definitely use it. Then immediately by applying activation function, you are finding these outputs. Now these outputs will work as an input for the next layer which we are calculating. And again immediately from this net input weighted sums, you are finding the outputs. Target values are given here. Always if you want, you can give them a notation YT1, YT2. Okay, again it is your choice. As per your convenience, you can use this notation. Forward pass properly you are applying, because number of times we solved this problem. So apply the forward pass, calculate all the values, and then when you are finding, updating the values of W5, W6, W7, W8, this is the pair for which you are updating the weights, and this is the pair for which you are updating the weights. Don't get confused in any derivatives. Observe the chain carefully. Error, it is dependent on difference between these two. Then next, this is dependent on this, and this is dependent on weights. So this chain every time it is followed. E, it is function of that output. Output, it is function of net input, that is weighted sum, and this is function of W5, W6. I hope it is clear to all. Some problems are given to you to solve. You can definitely see that problems, and I don't think it is difficult to solve any problem of back propagation.